Hello and welcome to the directions video for the Fluid Dynamics Lab. Here you can see I already have some fluid in dynamics, and let's talk a bit about the setup. So you're going to want some fairly large container like a 1-gallon plastic jug, and you're going to drill a hole in it. In this case I have 2 holes of different size already drilled, which actually isn't the best way to do it. It's better to drill 1 hole at a time and enlarge the hole for the different parts of the experiment. Okay, you're definitely going to want to have it a fair height off the ground so you can get a good range of projectile motion. And you're going to want to make measurements of the depth of the water, the height of the table off the ground, and the range of the projectile water. So you can do this outside like I'm doing it, or you could do it in a shower or something like that. Okay, so just real fast, the idea of making measurements. So one of the measurements that you would make is going to be the range along the ground from the edge of the table. And that would be your horizontal range. You'd want to find a point exactly below the edge of the table, or more importantly, exactly below the point where the water becomes airborne. Okay, so that's going to be your horizontal range. You'd want to measure that carefully. I'm just holding the measuring tape here as an example. You'd also want the height of the table. So you're going to need that because that's going to allow you to calculate your time of flight, which then is going to allow you to calculate the initial velocity based on the horizontal range. And the initial velocity being the velocity of the water, which you assume is horizontal. You can see it looks like it's coming out at an angle. That does depend on how you cut the hole. You want to cut the hole to encourage it to come out horizontally if possible. And we are assuming that even if it looks like an angle, the very initial velocity is entirely horizontal. That last measurement that I mentioned is the depth of the water. So let's go ahead and add some water back to this container so we can get a reasonable depth. Okay, excuse me. Okay. So you would want to have a particular depth, and then you would want to correspond that depth in centimeters to a particular range. Because what's going to happen is as your depth changes, your velocity will change as well, and thus your range will change. So you want to make sure that you match that up. You can do it as maybe separate measurements, so have a depth, and then take the measurement right away, or fill it up above that depth and wait till it gets there, so you don't have to be rushing and moving your measuring tape as quickly as possible. Because another measurement you're going to make is periodically over time, you're going to re-measure the height to find out how quickly the container drains, and if it drains at a steady rate. Okay, and you should find that the rate does not remain steady, that in other words it drains faster at first, and then as the velocity decreases and thus the amount of fluid that's actually coming out decreases, the draining rate slows down. So it's an interesting relationship. Okay, so that's a big part of the initial experiment, just getting corresponding a range to an initial velocity, and then initial velocity to a depth based on the Bernoulli principle of fluid dynamics. All right. You also need to use an approximation of the Bernoulli principle called the Torricelli theorem. Now, the other part of the experiment is to vary the size of the hole and see how that affects the initial velocity and also the validity of the 2 approaches, the Bernoulli approach and the Torricelli approach. And so here I have another hole. It's already drilled. And I'm going to fill this back up one more time to illustrate that. And you're never going to have 2 holes at a time. And so to kind of show that idea, I will cover up my initial hole when I open the larger hole. All right, so let's cover up the smaller one. And you can see this really drastically changes the system. And it should change the different approximation methods that we make as well. All right, because we can see it's really draining much faster. That bigger hole doesn't behave the same as the small hole. Okay, so that is the idea of the Fluid Dynamics Lab, and I think it's going to really kind of give you some fairly accurate data and show some interesting relationships, including that idea of seeing which level of simplification the Torricelli approach or the Bernoulli approach really is best for this problem. All right, well, I hope this video has been informative and interesting.